Let's work an example where we compute the current flowing through a pair of resistors, either in the case where they're connected in series or the case where they're connected in parallel. In case A, I have two 3-ohm resistors connected in series. They're straddling a point A, which is at 12 volts potential, and a point B, which is at 0 volts potential. I know that the voltage drop across this pair of locations is going to equal I times the equivalent resistance. The equivalent resistance here is 6 ohms because the two resistors are in series, and I know that when I have two resistors in series, I simply add their resistances. Therefore, the current will equal the voltage drop of 12 volts divided by the equivalent resistance of 6 ohms, and this equals 2 amps. For the parallel case, I know that the voltage drop, VAB, will equal I times the equivalent resistance. The equivalent resistance is equal to 1 over a quantity 1 over 3 ohms plus 1 over 3 ohms. That's equivalent to 3/2 of an ohm, because that's 1/3 plus 1/3 is 2/3, and I have to take 1 over it, so that's 3/2. So the equivalent resistance is 3/2 of an ohm. Notice that's less than the original resistance of either of the two resistors by themselves. Two resistors in parallel always gives you a smaller resistance. The current flow, then, will be the voltage drop divided by the equivalent resistance, or 12 volts divided by 3/2 of an ohm. This equals 8 amps. Notice that the current flow passing through a pair of resistors in parallel is much larger, in this case, than the current flow when those same two resistors are connected in series.